Suppose you wanted to find the equation of the tangent to this function y equals x squared minus 6x plus 8 at x equals to 1. Here's how you do it. First, we're going to draw a little sketch over here. Not the best parabola I ever drew, but you get the idea. Next thing, what I would strongly suggest to do is you find out the y-coordinate that goes with x equal to 1. So when x equals 1, y equals 1 squared minus 6 times 1 plus 8, which is actually 9 minus 6, which is 3. So now we know that the point we're talking about is 1 comma 3. It's probably here. Okay, and what we're trying to do is find the equation of the tangent line, which I believe is something like that. We're going to need to find the slope of that tangent line. Well, the slope of the tangent line is something we've been calling something else for a long time. It's called the IROC. And the instantaneous rate of change, it starts off being just the slope equation from one point to the next point, and we're going to call the 2 points x and x comma f of x, which is going to be our original point, and x plus h comma f of x plus h. But the thing is, and I'm only going to do a very brief explanation here, we're going to take this point and we're going to move it closer and closer and closer, and as you can see, the secant gets closer and closer to the tangent. So the equation that we're going to grow to love and realize is so important is this one here. The instantaneous rate of change of a function is the limit as h approaches 0 of f of x plus h minus f of x all over x plus h minus x. Now most people don't write it like that because they see that the bottom can be simplified. So they just write it like this. But I just want to remind you that it comes from grade 9, just finding the slope using rise over run, and then using grade 11 function notation. So we're going to try and evaluate this expression for this given function. That's our f of x right there. Okay, so what we're going to do is we're going to start off by leaving the h alone on the bottom. And what I'm going to do is I'm going to write f of x here. I always do it backwards. F of x goes there. And f of x plus h is just the same function that we have here, except now it's x plus h. That's the input of the function. So it's x plus h squared minus 6 times x plus h plus 8. And then what we do is a bit of algebra. So first thing we're going to do is we're going to expand the x plus h squared, and of course we're not going to forget the middle term. We're going to expand this other little bracket here, except we're going to make sure we don't make a mistake there. It's actually minus 6 minus 6h. So don't make that mistake. Minus x squared plus 6x minus 8. Don't make a mistake there either. All the signs have to change because of this minus sign. It affects all the terms in the bracket. This is like a minus 1, which you're distributing to all the terms. Now I'm going to grab my red pen here because I notice a whole bunch of really awesome stuff happens. This term wipes out. The 8's wipe out. The 6x wipes out. It looks like every term in there that contained no h's wiped out. That is not a coincidence. So then what we're going to do is we're going to simplify this a bit. 2xh plus h squared minus 6h all over h. Now here's the thing. This is a much simpler expression, and we want to know what this expression is equal to as h gets really, really close to 0. If we try and substitute 0 in for h, you're going to get 0 plus 0 plus 0 on the top divided by 0. you're going to get 0 over 0 if you let h equal to 0. And that's not going to work for us. That doesn't make sense. That's called an indeterminate. So what you have to do is you have to actually keep going and do a little bit more algebra. So what we're going to do, if you didn't notice, is since all the terms contain an h, we're going to factor out an h out of everything. And then I'm going to grab my red pen because I'm very excited to see that the h's go away. And why that is so good is because the h's were what were causing the 0 over 0 problem. So now we can actually substitute h equal to 0 into our expression, and what you'll get is you get 2x plus 0 minus 6, or 2x minus 6. Now this is the first time we've done this, so it'll seem a little bit weird, but this is actually the instantaneous rate of change for any x. So in other words, this gives us a nice little formula to determine the IROC for any x-ray that we have. And you'll see that it's very, very important for what we're going to be doing for the next month. So, traveling up here, we want to know what the slope of the tangent is when x equal to 1. That's our point right here. So we just substitute 1 into the IROC expression, and you get 2 times 1 minus 6, which is negative 4. So now we have the slope, negative 4, and we have the point, 1, 3. The equation of the tangent, using our wonderful slope-point form, is very, very quick to deduce here. Y minus 3 equals negative 4, x minus 1. And we could be done there, but some people really like the y equals mx plus b form, so you might want to rewrite this. Plus 4 plus the 3 from the other side, plus 7. And that is the equation of your tangent. That's this line right here. And it does have a negative slope. It will hit at 7, it looks like, although our graph doesn't look nearly steep enough. But that's our equation of our tangent, and we're done. This is a very fundamental skill that you need to be able to do. Hopefully that helped, and we'll see you next time.